Wow. Welcome back to Chapter 15.8, Substitution in Multiple Integrals, or Change of Coordinates. It's also more commonly, I was blanking for a little bit there, but it's more commonly called Change of Variables integration. So instead of change of coordinates, think of it as change of variables integration. And now we're on the second video, which is where the region is defined in the limits of integration. So let's jump to that problem. And it comes from the book. I kind of ripped it out of a little part of the book. And this problem in the book actually tells you what to substitute stuff with. We're not going to do that. We're just going to try to figure out how the hell we're going to find this integral, okay? And you know how most integrals on Symbolab, they'll give you the step-by-step solution. Well, here's the step-by-step solution on Symbolab. Yeah, it cannot solve. Literally cannot solve this integral. It's so hard that their step-by-step solution just, just just breaks down. It doesn't know what to do. And I'm just going to double check that this is true. Let's throw the x squared plus y squared into that integral, into the parentheses to just double check. And look, it's working, right? It's working. And yeah, it's not going to be able to solve this integral. This problem is so hard that Symbolab can't even solve the integral. So what are we going to do, right? And we'll just let this run a little longer. Actually, I'll just pull it back up once I figure out if it's done or not. So how are we going to solve this, right? The idea is going to be the same as the first one. Whenever you have a substitution in multiple, when you have a change of variables type of problem where you need a substitution, step one is always to draw the region, right? Is to draw the region. And so we're going to do that from the bounds, okay? So I have x is equal to 4 over y, right? And that means y is equal to 4 over x, okay? And I also got x is equal to y over 4, which means y is equal to 4x. So my lines in this region then are going to be 1, 2, 3, 4, 1, 2, 3, 4, right? It's going to be like this line up like this. So this is y is equal to 4x, or yeah, let's write it that way. And then I'm going to have y is equal to 4 over x, which goes there. It also goes here, and it also goes here. And then I'm going to have this guy. All right, this is y is equal to 4 over x. And then I got my dy bounds, right, which are 2 and 4. So then here's that, and then here's that. And so my region is going to be this triangle-like thingy, which is not quite a triangle because there's a little bit of curviness to it. Maybe if I can draw this line better, you'll be able to see that. Right, yeah, there, that's better. So there's a little bit of this curvature going on. It's not a perfect triangle, and that's going to be my region right there. So here I got y is equal to 4 and y is equal to 2. And now we ask ourselves, how the hell do we find a way to substitute this guy? What in the world are we going to use? And so, like previous, we want to get x's and y's on the same side. So what does that mean? That means that here, right, when we have this equation, y is equal to 4x, I don't actually want to leave it that way. I want the x and y on the same side. So instead, I'm going to rewrite this equation as, let's write it in dark green, y over x is equal to 4. Okay? And then likewise, over here, the spot of this equation, I'm going to write it as xy is equal to 4. And now, I'm going to substitute. And by blind faith, I'm just going to take u equals y over x, and I'm going to let v equals x over y, okay? And this looks like I'm being really stupid, and it looks like I'm pulling shit out of thin air, but really, what are our lines, right, bounding this guy? I have this red line, y equals 2. Well, there's no reason to do like a u equals y sub, right? That doesn't make any sense. But then I have y over x, I have x over y, and then it makes sense to then sub these guys. So I'm going to do that. So then step 2 is to make your sub. right? And I'm going to say u is equal to y over x, and v is equal to xy. And so now my Jacobian is going to be the following. It's going to be the determinant of, all right, what's the partial of u with respect to x, right? So du dx, du dx is going to be, we've got to use the quotient rule. So it's x times 0 minus y times 1 divided by x squared. Right, and so that's negative y over x squared. And then du dy is simply 1 over x. Okay, dv dx is now y, and dv dy is going to be x. So that's, the last one was fine, the first one was kind of bad. And so the Jacobian then, oh, and we got to take this inverse, right? Remember, we have to take the inverse because we got u equals and v equals, right? So we got u equals and v equals, so we got to take that inverse. All right, and now what does that equal to? That is equal to negative yx minus yx, so I get negative 2y over x. I got to take the inverse, and now I get x is over negative 2y, but now I can't have any negative signs, right? So this can't be a negative, okay, so it's negative 2y over x, or a negative x over 2y, but now I can't have the negative sign, right? I've got to take the absolute value of that, so my Jacobian really is equal to a positive x over 2y. So how in the world am I going to stick that into the equation, right? So step 3 then is to so this is still step 2. We got to sub it into the equation, right? So this first part was just calculating Jacobian. So now I got a double integral of something. I got x squared plus y squared, right? Dx dy. I think it's dx dy. It might be dy dx. Yeah, it's dx dy. So what is x and what is y, right? Because here u is equal to y over x and v is equal to xy. They aren't anywhere close to being x squared plus y squared, right? Where in the world does this link come from? And this is where we have to play with the variables u and v to get an x squared plus y squared. So what do I mean by that? So let's consider, all right, so this is the Jacobian, all right. Now we got to solve this integral, right? So what's our problem? Our problem is, what is x squared and y squared in terms of u and v? Right? What are x squared and y? What are? Wow, my grammar is 6th grade level right now. So what are x squared and y squared in terms of u and v? Right? Because here u is y over x and v is xy. It's not as straightforward as in this problem up here, right? Where simply, oh, look, xy was that, right? So not as straightforward in this problem. So, okay, we got to play around with u and v. So what happens, let's say, up here, okay, let's bring these guys back. What happens when I say, like, what is u times v? Well, u times v is y over x times xy. Hey, look at that, it's y squared. Okay, so now I got to find an x squared, and maybe if I do some dividing I can get one. Well, it looks like, what if I have v divided by u? Well, that's xy divided by y over x, and that's going to be equal to xy times x over y. Hey, look at that. That is x squared, right? So now we see that y squared is equal to uv, and v over u is equal to x squared. Great. So in the substitution, x squared is going to be vu, and then y squared is going to be uv. And then now I got to multiply my Jacobian in, but my Jacobian right now is in terms of x and y as well, right? So that's a problem. So now I need to make my Jacobian in terms of u and v. And what is that? Well, this one's a little easier, right? Because we got essentially, this is the same thing as 1/2 x over y, right? But we have a y over x. We have a y over x, which is u. So then, in terms of u and v, we can see that, oh, hey, look, the Jacobian, it looks like it's equal to 1/2 times 1 over u, right? Since 1 over u is equal to 1 over y over x, which is x over y. So that's fine. That looks like it's going to work well. And so now we got to multiply the Jacobian in here, which is, what did I say it was? It was 1/2 times 1 over u. And now we got to find the limits of integration. So step 3 is to draw the new region, or before we draw the region, we're going to translate the lines. We want to translate the boundary lines and draw the new region. So what does that mean, right? Previously, in the previous example, it was really easy to figure out what our bounds were because we'd simply say, okay, this guy is actually just u equals 4, and this guy is just v equals 4, right? But however, that just means we have two lines translated of a region, right? We still got this red line here, y equals 2, that needs to be translated as well. So we have two lines, right? We have y over x equals 4 becomes u equals 4, and we have xy equals 4 becomes v equals 4, and I really hope I did that correctly. Okay, yeah, that's fine. But now I have one last line in my region that I need to consider, right? This red line right here is part of my region, and I need to translate that into u and v as well. And the equation of my red line is y equals 2. Okay, and so now I have to consider, wait, how in the world am I going to get y equals something, right? And how am I going to get y equals? Well, this one, this job is a little harder, but hopefully you guys can see it. We can get y equals 2, right, from taking, if you let, I'm trying to figure out a good way to explain this. Y equals 2. Okay, the way we get the line y equals 2 is the following way. So y, right, so u is equal to y over x, and v is equal to xy. Y equals 2 is equivalent to the line 4, v is equal to 4 over u. Okay, and I'm not comfortable just saying this, but why is that true? Well, if we consider it, here, now you get the following, right? You get xy is equal to 4 over yx, all right? And then what now? Hold on, I have a better way of explaining this. Y is equal to 2. Why is that true? Why is y equal to 2 true? Oh, okay. I got it. All right. So how do we find y is equal to 2, right? So you have u is equal to y over x, and v is equal to xy. All right. So what we have to do here then is we need to isolate y by itself. So we have y is equal to xu, right? And then from here we take this equation and we plug y is equal to xu into that guy. which now says v is equal to x times xu. All right, what does that mean? That means v is equal to x squared u, and now v over u is equal to x squared, okay, which we actually found this earlier, right? We actually know this earlier, so I'm being just dumb right now. X squared is equal to v over u, and that means y squared is equal to uv, right? So we have this from earlier. Y squared is equal to uv, and so to find y then, the square root of uv is equal to y. So y equals 2, right, implies that, oh, the square root of uv is equal to 2, which means uv is equal to 4, and then v is equal to 4 divided by u. Okay, so that's going to be the line v is equal to 4 divided by u. All right, does that make sense? So that's how I get y is equal to 2 translated into v equals 4 over u. Yeah, so this guy right here, we had to go through all this work to find v is equal to 4 over u. And yeah, I just essentially forgot. If I remembered this relationship right here, it would have occurred much quicker, right? Because then I know what y squared is, so y is equal to the square root of uv, and then if y is equal to 2, then that means uv is equal to 2 if y is equal to 2, right? Or root uv is equal to 2, and then from there you can just solve for v, or solve for u, it doesn't matter. So now I got my 4 lines, and so I want to draw my region now in the uv plane. Okay, and what is my region in the uv plane? I got u equals 4, u equals 4, I got v equals 4, and now I got this line v equals 4 over u, which then at u equals 1 I get v equals 4. Okay, so at u equals 1 I get v equals 4, at u equals 2 I get v equals 2, and then at u equals 4 I get v equals 1. Right, so I get this line right here. And now my region has to be bounded by all 3 lines, so it's going to be this region right here. And let's write in the equation, this is v is equal to 4 over u. And so now we can go back up here and we can figure out what is the limit of integration, right? So now step 4 is to set the limit of integration, or find the limits of integration. Right. So what did we had? We had a double integral of v plus vu plus uv, and then there's like a 1/2 times 1 over u, but I'm just going to bring up the 1/2 out in front. And then we got 1 over u, and now we got either du dv or dv du. But looking at this graph right here, we already solved for v, right, in terms of u. So we'll just integrate with respect to v first, okay? And to integrate with respect to v first, then we draw a line through our region, like that. It hits the curve, which is v equals 4 over u, and then it hits that straight line, v equals 4. So I go from 4 over u to 4. And then I need to integrate with respect to u, which means I need to find my minimum value of u, which is 1, right, which is that guy. And then I need to find my maximum value of u, which is going to be 4. Right? So then I'm going to integrate from 1 to 4 with respect to u. So, and then the inside integral is dv, and the outside integral is du. Okay, so hopefully this setup makes sense. And now this is just a technicality. We just need to be able to integrate this. So what is it? Well, it's 1/2. Here's 1/4. Multiply the u through, 1 over u through. So this is equal to v over u squared plus just v now, dv du. Okay, so now we integrate the first guy. We have 1/2, 4 over 1. Now this becomes, what is it? We're integrating v, so this is v squared over 2? hold on, let me make sure I have this correct. I'll fuck this up this late. Yeah, okay, v squared over 2. Well, you have a 1 over u squared first, and then you got v squared over 2 evaluated from 4, and on the bottom at 4 over u, and then you want to add then v squared over 2 evaluated from 4 over u to 4. And then you got du left. Okay, and what is that equal to? That's equal to 1/2 times the integral. That's not an integral, that's a bracket. Times the integral from 1 to 4. That doesn't look like an integral either, but it's fine. And, oh, sorry if my paper's been running into the microphone. I haven't been paying attention, as this video's gone 20 minutes and we're still deep in this problem. So, what do I have now? You get 4 squared, which is 16, over 2, which is 8. So you get 1 over u squared times 8 minus, well, 4 over u is just really 8 over u squared, right? So it's the same coefficient, but now you just got to over u squared on the bottom. And then plus, then you get the same thing. You get 8 minus 8 over u squared, right? There's just no 1 over u squared multiplying it out in front. Du, okay? And if we multiply the u through, or 1 over u squared through, we get 1/2. Then you go from 1 to 4. This becomes 8 over u squared minus 8 over u to the 4th, and then this plus 8, and then minus 8 over u squared du, which actually works out pretty nice because these guys kill each other. And now you got 1/2. Okay, the integral from 1 to 4th. Ooh, pots and pans clashing outside. You got 8, and now I'm going to write this as 8 u to the negative 4th. All right, I'm just rewriting this guy differently. Makes the integration a bit easier than dealing with some fractions. And du. And so now, what is this? This is 1/2 8u minus 8, or plus, minus a negative 8/3 u to the negative 3, right? Because that's how we integrate that guy. Evaluated from 1 to 4, which is equal to 1/2 times, okay, this is 32 minus, or plus, right, because a minus and negative is a plus, plus 8 over 3 times 1 over 64, all right, minus 8 plus 8/3. Okay. Ooh, we're almost there. We are so close to being done here, and I hope I didn't screw any of that up. I'm just going to look real quick. I don't want to accidentally make a moronic mistake this late in the problem. I think it's fine. Okay, fingers crossed. That should be fine. And then this is 1/2, right? So what do I get? I get 32 plus 8 and 64. They do some canceling, right? That let's use a different color. I have so many colors on hand. Why not? So that cancels. That cancels. This becomes 8. So it's 32 plus 1 over 24. Okay, and then minus 8, and then plus 8/3. So that's 1/2 24. Plus 1 over 24 plus 8/3, and this guy right here, what is he? Oh wait, this is minus 8/3. My bad. Minus. Wow. That was so close. So close to being bad. I copied it down wrong because it's minus. This minus sign has to distribute through the plus sign, so then this guy becomes a minus sign. Okay, minus. That's a minus. So now this becomes 1/2. Bear with me. 24 plus 1 over 24. Let's just do the fraction guys first. So this becomes plus 1 over 24 minus 64 over 24, right, which is now 1/2. 24 plus 63 over 24, which is 1/2. 24 plus 21 over 8, factor out a 3 from the top and the bottom, which is 1/2 times 192, minus 63 over 24. Wow. Sorry about that, right? Because this guy is minus 63 over 24. Okay, hopefully you guys got that. And then this becomes 192 over 8, which is 24, minus 21 over 8, which is 1/2 times 171 over 8. And we get 171 over 16. And this is the correct answer. I plugged in this guy up here into Wolfram Alpha, and that got me the exact same answer as this guy down here. So, wow, what an involved problem. I don't think you'll see anything as hard as this on an exam. Hopefully not. It took us almost half an hour to get through this one example. But yeah, so this is the second example of when the region is given in the limits of integration. So what did we do? We drew our region first, and then we looked at the lines that weren't like really simple, right? So we looked at the lines like this guy, where we had x and y's on the same side, and we looked at like this guy, where we had x, y's on the same side, and we decided to let our substitution u and v be representative of these two lines circled in purple, right? And that's because it makes no sense, right? It makes no sense to substitute u or v is equal to y, because what the hell are we doing? We're just renaming the variable y in that case. So that means we're going to substitute these guys, we're going to make that sub, and then, okay, so we find that Jacobian. Cool, we find the Jacobian. And then what we want to do then is we want to set everything in terms of u's and v's. So we want to find x squared and y squared in terms of u and v, and we find the Jacobian in terms of u and v as well. And we're able to do that, which is this box, red box over here, right? We find x squared and y squared in terms of u's and v's, which is u times v and v over u. And then, okay, now we substitute our integral, but the next step we need to do is to translate the boundaries and lines, which, you know, some of them are easy, right? Because xy is equal to 4. Well, that's just v is equal to 4 by this line right here, right? V is going to be equal to 4. And then y over x equal to 4. That's easy. That's u is equal to 4. So then the hard guy, this one was the hard guy to figure out, is how do we find y equals 2 in terms of u's and v's. And then that means we have this entire step over here. Really, you can ignore everything up to here, right? So starting from here, we know that uv is equal to y squared already, and that's because up here as well, right? uv is equal to y squared, and so we just use that relation down here, and then we know that, okay, square root of uv is equal to y. And what else? I know that y is equal to 2, right? Y is equal to 2 is my line. So then we get root uv is equal to 2, uv is equal to 4, we get v is equal to 4 over u. And then we need to draw the region, okay? And then we drew this region right here, very important. Figure out our limits of integration. And then after we do that, we're good to integrate. And then over here, all the way at the bottom, is just making sure we don't make dumb sign errors. So half an hour problem. Hopefully this was really helpful to you guys. Again, I don't think anything is going to be this hard. And as a bonus to the end of this video, let's see if Symbolab ever figured out if it can solve the problem or not. The answer is it can't solve it. So congratulations, you literally just solved the problem that Symbolab can't solve. Wolfram Alpha gives you the answer, which is 171 over 16, which is exactly what we got, which is good. But Wolfram Alpha doesn't give you the directions. And if you actually try to solve this integral, if you actually just try to solve this integral right here, it's actually really bad. It actually turns out so bad. Yeah, it's a good exercise. Tedious as fuck, but hopefully you guys learned something. And we're done with 15.8. We're moving on to chapter 16. There's only 8 more sections left to cover, and then 114 is donezo.